Okay folks, I'm going to explain in very simple terms how a two-stroke single-cylinder engine works. What I've drawn here is the cylinder and block assembly of a two-stroke engine. Now the example that I'm showing, I'm not adding separate components and stuff like that. We can get into that complexity when we start looking at one as it's dismantled. This is on its side just because it sits nicer on my little screen here. Here's your spark plug. Here is your crankshaft, and this is the counterweight on the crankshaft, which is on the opposite side of the connecting rod. And I've done a zigzag through here, which basically means that the connecting rod's cut off because I'm going to be using this piston to simulate the action of the strokes, and I can only draw this in one position. So that's the counterweight, this is the connecting rod. Picture that your piston's connected right in here, and then every time this thing rotates, this counterweight would swing in the opposite direction of the connecting rod to offset the force of the connecting rod when it's being pushed during a power stroke, just to keep the engine a little bit more in balance. This is the crankcase down here. This is your cylinder, and here's your combustion chamber. So when the piston comes up in the cylinder, it basically comes to about there, and you have a little bit of a hemispherical. That's where the term Hemi comes from, by the way. Hemi is short for hemisphere, and Dodge did a brilliant thing back in the 60s by actually patenting. They took out a patent on the term Hemi, and then they claimed that. There's all kinds of engines that have hemispherical combustion chambers, but Dodge, Chrysler are the only ones allowed to use the word Hemi because they patented the term. So brilliant piece of maneuvering there. You can see the bottom of the spark plug electrodes right here. Okay. The thing you have to remember, first of all, the four stages of events that occur when an engine runs: intake, compression, power, exhaust. Normally you don't hear the word stage, you hear the word stroke. Intake, stroke; compression, stroke; power, stroke; exhaust, stroke. Well, that's because on a four-stroke cycle engine, the stage, in other words the event, occurs during the stroke. So intake happens during intake stroke. Compression happens during its own stroke, during the compression stroke. Power occurs during a stroke. Exhaust occurs during a stroke. In a two-stroke cycle engine, those same four things happen. You have intake, you have compression, you have power, and you have exhaust, but they occur within two strokes of the piston instead of four. And so I want you to think about the stage of the event, and the fact that in this case it's not necessarily paired up with it's never paired up with a whole stroke. But think of it as a standalone event as opposed to being married to a stroke. Okay. The second thing is that the two-stroke engine basically has two batches of fuel mixture in it at the same time. So I'm going to lay the piston in here, and by the way, for those of you sharp-eyed, hawk-eyed people, this is actually not a two-stroke piston. And there's some visual cues on here. There's clues as to prove that that's not a two-stroke piston. Well, the big one is this. This is actually an oil ring, and that's meant for a four-stroke engine. And a two-stroke engine doesn't actually have liquid oil rolling around in the crankcase, so as a result, it doesn't have to have a ring to, first of all, wipe the cylinders with oil and then squeegee them off. And it doesn't have to control oil flow up the cylinders because there isn't any actually oil in there. Oil is either being injected into the crankcase with an injector. Normally it's aimed at the crankshaft. That's one option, is that it's injected. Old school, you actually take some two-stroke mix oil and you mix it with fuel at a correct ratio specified by the manufacturer, and when the fuel comes into this engine, it has oil in it, and the oil basically comes in as a vapor, and every time you have an intake event, you have a little bit of oil vapor come in with the fuel, and that oil vapor is sufficient to coat the bearings and lubricate the parts. Alright, let's put the piston right there. Okay. So don't roll. Okay, while the engine's running, you have a batch of air-fuel mixture up above the piston. You also have a batch of air-fuel mixture down below the piston. When I'm teaching four-stroke theory, I'm spending a lot of time talking about the pressures in here. Okay, so let's do four-strokes. Let's pretend this two-stroke part doesn't exist for a second. We'll start at top dead center, the highest position the piston can be in. This will be your intake stroke. Okay, your piston goes down. There's one stroke, and it draws in a batch of air-fuel mixture. Now, I don't have valves or intake ports or anything here yet, so you have to use your imagination as to where it would come in. But the point is, this draws down, creates a vacuum in here, and sucks in air-fuel mixture. Second event in four-stroke gets its own stroke, compression stroke. Second event is compression. There's your compression. And then your spark plug fires just before top dead center. And then you have your third event, which is your power stroke or your power event. And the explosion occurs here, pushes on the piston, drives the piston downwards. And then your fourth event is your exhaust, where the piston goes back up and shoves the exhaust out the exhaust valve. Now I made a point of, during intake you got low pressure. During compression you got high pressure. During power you've got very high pressure. And then during exhaust you actually have high pressure as well, because this is pushing, right? Anything that's in here is going to get compressed, squashed, and shoved out the valve. So you have high pressure there as well. Also, the tail end of the power stroke, you just had an explosion. All the gases in here are very, very hot and they're still expanding. So you got high pressure there. Now what you have to remember is that the whole time that the piston is moving up and down in the cylinder, the movement of the piston generates pressure changes down here as well. Okay, so just for a moment, if we take the intake stroke of a four-stroke engine, intake, piston goes down. Well, let's look back over here. Let me start it over this way. When the piston moves this way, you can picture in your mind, I hope, that that's almost like a compression stroke for this side of the motor. The piston starts out here. You've got all this volume of space with a crankshaft in it, and then crankshaft rotates, connecting rod pulls, and your piston moves down. Well, the amount of volume of space has been reduced because the piston moved towards it. So as the piston moves this way, this space actually gets compressed. Okay. Then when the piston goes back up this way, this volume here goes from a small space to a large space. That creates a low pressure or a vacuum. And this all happens in a four-stroke engine as well. It's just that it doesn't really get used for anything. Okay, you have a system on your motor called a crankcase ventilation. It's actually called PCV, which stands for positive crankcase ventilation. It's an entire system in a car engine. It's very complex. But you're basically managing the pressures down here, because downward movement of the piston causes high pressure here, which can actually push oil out through passages and seals and gaskets and cause all sorts of problems. Upward movement of the piston, that is a vacuum, which could theoretically draw things in here. So in a four-stroke engine, the pressure down here is changing all the time as well. The PCV system basically vents that pressure out and manages it. Okay. Now back to two-stroke. What your two-stroke engine does is your two-stroke engine uses both halves of the motor and both of those pressures at the same time. And the engine has two batches of air-fuel mixture in it at the same time. One of them is going to be up here, one of them is going to be down here. And so it's a little tough to get your head around, which is why I always teach four-stroke theory first, because it's a little more, I don't know, it's a little more symmetrical, I'll say. You got an event and a stroke. You got another event and another stroke, etc. Here you got two things going on during each stroke. So I'm going to start with the piston in the down position. And you guys have to think along for a second here that you've already got an air-fuel mixture up here. We'll figure out how it got there, okay? There's parts to this drawing that aren't complete yet. But in your mind, imagine that you have an air-fuel mixture in here. Don't worry about how it got there. It's there. Trust me, okay? Now, piston's going to start going up. Okay, so up here you have a compression event, right? This is not a compression stroke, it's a compression event, because if you remember what I just explained, as the piston moves up, down here we have a vacuum. We have a low pressure event because the piston goes from, or sorry, the crankcase goes from small volume to larger volume. So you have a vacuum in here. Well, that vacuum, or low pressure, gets used as an intake stroke. Okay, so this first movement of the piston does two events. The batch of fuel that's up here, batch of fuel and air that's up here, actually gets compressed. So you have compression up here. Down here, I mean, picture this. All right, let's do it that way. Pretend the piston's turned that way. It isn't, but pretend. All right, if the piston went that way, all of a sudden, isn't that an intake stroke? And it is. Okay, we'll turn it back again. No matter which way the piston goes, technically it doesn't matter because the piston seals off the cylinder. So no matter which way it faces, it's sealed off in the cylinder, and when it moves, it creates pressure changes on either side of it. Hope that makes sense. It's the best I can do. Compression up here, vacuum down here. Now I'm going to draw the intake of the carburetor in a spot that doesn't match snowmobiles, and it doesn't match dirt bikes very well, but it matches string trimmers and whippersnippers and chainsaws and stuff like that. And also because I'm a little crowded here, I'm going to make it over here. Okay. So, and just to make this really fast and easy, this is going to be your carburetor, and then we will put an air filter on it right there. Okay. And here